So in this question it is given that if the value of acceleration due to gravity at the surface of a sphere is am, then the value is am by 3 at a distance dash from the center. So in this question they are given the acceleration due to gravity on the surface. So we know that if you are considering what about the value of acceleration due to gravity on the surface, so that equation is going to be nothing but gm divided by r square. But if you are considering a point which is h height above the surface, or if it is at a distance r below the surface, then the value of acceleration due to gravity is going to change. So in this question it is given that this acceleration due to gravity is decreased, and now the value is nothing but am divided by 3. So acceleration due to gravity is going to decrease. So remember that there are two possibilities. One is we can move into the earth, or we can move away from the earth. In both the situation, the value of acceleration due to gravity is going to change. And in question they are asking what about the value of distance from the center. So there are two possibilities. A point inside, let's say point P1, which is a distance r from the center, or a point P2, which is the distance r from the center, and both the point the value of acceleration due to gravity can have a value that is equal to gm by 3. So we need to consider both the situation. Let's see the first situation. So we know that acceleration due to gravity inside a solid sphere or inside earth is equal to gm into r divided by r cube. So in this question this value is given as the 1/3 of acceleration due to gravity on the surface. So we can write this gm into r divided by r cube is equal to acceleration due to gravity on the surface. We know that is gm divided by r square. So into 1/3. Instead of this g naught, I am just writing it as gm divided by r square. So we can cancel this gm and this gm, r square and r square over here. So remaining thing is r divided by small capital letter R is equal to nothing but 1 divided by 3. So I'll get the value of this r is equal to r divided by 3. So this can be one option. So in question, the value of acceleration due to gravity at the surface of a sphere is am, then the value of am by 3 at a distance r from the center is. So the value of r is going to be r by capital letter R divided by 3. So in option it is given that small letter r by 3. So this might be considered as nothing but the r is small letter r is taken as the radius of earth. So this can be one of the possible answer. Then there is one more possibility is there. If you are considering the point outside the earth surface. So if you are considering a point which is outside the earth surface, so let's say this is distance r from the small letter r from the center. So we know that gravitational field outside is equal to gm divided by small letter r the whole square. So we can write the value of g, and this question is given that just gm by r square is 1/3 of that on the surface gm by r square by 3. So we can cancel this gm and gm, or we can write the value of 3 into r square is going to be r square, or the value of r will be equal to under root of 3 r square, or the value of r is going to be root 3 times of r. So there are two possibilities. At a distance root 3 into r, or at a distance of r by 3, the value of acceleration due to gravity can have a value that is am, or acceleration due to gravity on the surface divided by 3. But according to the given options, only in D option it is given. We don't have an option like root 3 into r.